I think one area that where HSS probably has a lot of value but is underutilized is, we generically call it the industrial sector. And that can be anything from, warehouses, which HSS is already very strong in warehouses because of the long, tall columns. But when you get into things like battery plants being built, chip plants, where they have clean rooms, those are areas where people are concerned about the cleanliness of what goes on in the structure. Well, HSS, because it doesn't have any ledges, it doesn't collect dust, and you can seal the connections and you can do all these things. So we have a lot of engineers that come to us and saying, well, I'm being asked to do a project that I haven't done before, and HSS makes sense. Food processing is another area where we see that cleanliness aspect. So those are areas where engineers are starting to see more and more projects come up, and they may not have the experience. And so that's an area we wanted to be able to add our expertise and bring our collective knowledge together to share that with other engineers.
Yes, I think it's good to check. Always have a comparison with the HSS, especially as you have longer unbraced lengths, because if you start looking at the column in terms of capacity, dollar per capacity, you can have some significant savings in the overall amount of steel that you're using. So especially with the longer unbraced length columns.
One of the basic benefits of HSS is that you have material away from the center, and that means that you're going to have a lot of compression capacity even when you have long lengths. And because industrial structures are often in tall spaces, dealing with large machinery and that sort of thing, and not only tall spaces but also heavily loaded, that's a situation where having an efficient cross-section is going to bear the most fruit. And so, I think to a certain extent industrial applications, as with any application, there's a tendency to do what people are comfortable with, to do what has been done in the past, and certainly using wide flange columns is not going to cause a problem for the structure in terms of its actual use, but it is leaving performance on the table, or it's leaving, economy on the table when it comes to the design of those structures.
When it comes to the industrial applications, as Ted pointed out, people tend to do things the way they've always done them, and with long unbraced lengths and higher loading, and maybe not as many diaphragms as an office building would have, and so therefore that leads to those longer unbraced lengths. But one of the things I think that has prevented people from considering HSS for industrial applications was the limit in the size range. We used to stop at 16-inch square, 5/8" wall, and comparatively that's a fairly reasonable or mid-range size of wide flange comparisons. But with wide flanges going up to into the really large sizes now, engineers didn't have that option to carry those heavy loads at those long unbraced lengths. Either they had to look at a built-up box section or a cover-plated wide flange. But now with our jumbo mill that we're producing some of the largest sections available anywhere in the world, we actually now can compare to some of the heaviest wide flange sections out there. So if you have heavy loads and long unbraced lengths, you can bring the 18 square, the 20 square, the 22-inch square, and all the way up to the 1-inch wall. We can start to carry some significant loads using a lot less steel.